5.1 Rate of change and slope of the line. Slope is nothing more than vertical change over the horizontal change, in other words, rise over run. In the chapter, we'll discuss a horizontal line which has a slope of 0, which basically means it does not rise any. And then there's also the other special case that we're going to discuss during class, which is a vertical line which has no run, which is straight up and down, is undefined. The examples here are just going to be standard slopes though. So what we want to do is we want to find the rise over run. So we connect the dots and we count that we rise up 3 and we go over 5. So when we set up the slope then we have m, which is the denotation of slope, rise over run, and as we counted, 3 over 5. This does not reduce, so the slope is 3/5. For another example, we have to have a downward slope. Notice that we go down 1, which is negative, and we're going to go to the right 4 spaces, which is 4. Here, our rise over run, our rise is actually downwards 1, so it's -1 over 4. The problems that we just completed are just moved up to the top. Instead of counting on a graph, we can actually solve these algebraically. So we have the slope is the rise over run, which basically is our change in y, and the run is our change in x. So to find this then, we have to denote our points. We're going to call the first coordinate x1, y1, and the second one x2, y2. Notice I color-coded these. So our slope is going to be y2 minus y1 over x2 minus x1. We're subtracting here because we're trying to find the difference in the values. So 5 minus 2 and 6 minus 1. 5 minus 2 says our difference in the y direction is 3. 6 minus 1 says our difference in the y direction, x direction is 5, as we had shown up above. So for the next example, we have the 1, 0 and the 5, -1. So again, we do note the points x1, y1 and x2, y2. Our slope then is our y2 minus y1 over our x2 minus x1. Again, we're finding the difference because we're finding how much they change. So -1 minus 0 is -1, and 5 minus 1 is 4, and here again we have the same solution.